For centuries, Betelgeuse has shone above humanity as a deep crimson light resting on the shoulder of Orion. Its reddish glow, visible to the naked eye, has made it one of the most recognizable stars in the night sky. A familiar presence in a sky that has inspired human curiosity for thousands of years. Across ancient civilizations, people observed it carefully and wove it into myths, navigation, and seasonal traditions. Many cultures noticed its changing brightness and tracked its position among Orion's stars. To some, it represented the shoulder of a celestial hunter. To others, it served as a guide for travel, storytelling, and survival. Sailors once used its light to navigate across oceans, while travelers in deserts followed its glow across open horizons. Yet even long ago, observers realized something unusual about it. Unlike many stars that shine steadily, Betelgeuse appeared to change subtly over time. Its brightness rose and fell with a slow rhythm, almost like a distant heartbeat in space. Over generations, the star became more than a bright point in the sky. It symbolized change hidden within apparent stability, reminding observers that even the heavens are constantly evolving. Modern astronomy has revealed the extraordinary reality behind that familiar glow. Located around 640 light-years from Earth, Betelgeuse is close enough in cosmic terms that the light reaching us today began its journey when human civilization was still in its early development. Every ray of light from the star is effectively a message from the past. In space, distance and time are deeply connected. Although its surface temperature is cooler than the Sun, about 3,500 Kelvin compared to the Sun's roughly 5,800 Kelvin, Betelgeuse is vastly larger and more luminous. Its immense size allows it to radiate enormous amounts of energy despite its cooler surface. If it replaced the Sun at the center of our solar system, its outer layers could stretch beyond Jupiter's orbit, engulfing Mercury, Venus, Earth, and Mars. Betelgeuse is not a calm star. It is a red supergiant nearing the final phases of its life. Its surface is constantly changing, covered by massive convection regions where hot plasma rises from deep layers while cooler material sinks back down. These turbulent zones are enormous, large enough that entire planetary systems could fit inside them. The star's surface is always shifting, expanding, and evolving. Its atmosphere is equally active. Powerful stellar winds push gas and dust into space, creating huge arcs and clouds surrounding the star. Through this process, Betelgeuse continually loses mass, releasing material back into the galaxy. Elements formed inside the star, carbon, oxygen, nitrogen, and others, are expelled into space, later becoming part of future stars, planets, and possibly life itself. But this process also reveals instability. Red supergiants survive through a balance between gravity pulling inward and energy pushing outward. As these stars age, that balance becomes increasingly fragile. In late 2019 and early 2020, Betelgeuse drew worldwide attention when its brightness dropped dramatically. The dimming was significant enough to be seen even by casual skywatchers. Scientists immediately focused on the event. Some wondered whether this could signal the beginning of a supernova, the long-expected death of the star. If Betelgeuse exploded, it could become one of the brightest objects ever seen in Earth's sky, potentially visible during daylight and bright enough at night to cast faint shadows. However, further observations revealed a different explanation. The star had ejected a massive cloud of gas and dust that temporarily blocked part of its light from Earth's perspective. Betelgeuse itself had not faded, it had briefly obscured its own brightness. Deep inside the star, fusion continues in layers. Hydrogen transforms into helium, helium into carbon, and progressively heavier elements form deeper within. Eventually, this process reaches its limit. When iron accumulates in the core, fusion can no longer generate energy. Instead of supporting the star, the core begins to collapse under gravity. The final stage happens rapidly. The core compresses while the outer layers are thrown outward in a tremendous explosion, a supernova. For a short period, the event could release more energy than the Sun will produce during its entire lifetime. Yet despite its dramatic future, Betelgeuse poses no danger to Earth. At its great distance, the explosion would be an extraordinary astronomical event rather than a threat. The greatest mystery is timing. The star might explode tomorrow, or it could remain in this unstable state for tens of thousands of years. There is also another possibility. Because light takes time to travel, Betelgeuse may have already exploded, and the evidence is still crossing space toward us. Until that moment arrives, the star continues its restless evolution. Its brightness shifts. Surface eruptions appear and fade. Massive convection zones rise and fall as energy moves through its turbulent layers. Rather than behaving like a fixed object, Betelgeuse resembles a dynamic system constantly changing under immense forces. Its mass loss remains irregular, while internal pulsations reshape its atmosphere and produce new clouds of dust that form and disperse over time. Each new observation reveals more complexity, challenging scientists' understanding of how massive stars evolve. When the final explosion eventually occurs, it will not simply mark an ending. The elements created inside the star over millions of years will spread into interstellar space, later contributing to new stars, planets, and future cosmic structures. In that sense, Betelgeuse is not only approaching the end of its life, it is also participating in the continuing cycle of cosmic renewal. Astronomers still monitor it closely, studying every change in brightness and every shift in its behavior. Despite modern technology and advanced models, the star continues to hold mysteries. One day, its transformation will arrive. And when it does, it will illuminate the galaxy not as an ending, but as another chapter in the ongoing story of creation and change across the universe. Until then, Betelgeuse remains above Orion, bright, unstable, and constantly evolving, reminding us that the universe is never truly still. But there is an even deeper question surrounding Betelgeuse. What actually happens inside a star when it reaches the edge of existence? To understand its future, scientists look beyond the glowing surface and into the hidden layers beneath. Betelgeuse is no longer a young star powered only by simple hydrogen fusion. It has already moved far beyond that stage. Massive stars live differently from stars like our Sun. They burn fuel faster, evolve faster, and die far more violently. Deep within Betelgeuse, nuclear reactions occur in layered shells, almost like the layers of an onion. Hydrogen burns in outer regions, helium fuses deeper inside, while heavier elements continue forming toward the core. Each new stage produces less energy and lasts for a shorter period. Hydrogen burning can continue for millions of years. Helium fusion lasts much less. Later stages involving heavier elements may survive only thousands, years, months, or even days. As the star ages, time itself seems to accelerate. Eventually, the core becomes dominated by iron. And iron changes everything. Unlike lighter elements, iron cannot release energy through fusion. Instead of supporting the star, it becomes a dead end. At that moment, gravity begins to win. For millions of years, outward pressure from fusion fought against inward gravitational collapse. Once fusion stops supporting the core, that balance disappears. The collapse happens with astonishing speed. The core contracts in seconds. Temperatures soar into billions of degrees. Electrons and protons are crushed together, forming neutrons in an environment so extreme that normal matter itself begins to change. Then comes the rebound. The collapsing material slams inward and releases an enormous shockwave racing outward through the star. This is the beginning of a supernova. The explosion does more than destroy a star. It creates new matter. Many of the elements found on Earth, including calcium in bones, iron in blood, and oxygen in the atmosphere, originated inside ancient stars that ended their lives this way. In a sense, supernovas are cosmic recycling events. The death of one star becomes the material for future worlds. What remains after Betelgeuse explodes depends largely on the mass left behind. One possibility is a neutron star. Imagine compressing more mass than the Sun into a sphere only around 20 kilometers wide. Matter there becomes so dense that a teaspoon would weigh billions of tons. Another possibility is even more extreme. If enough mass survives the explosion, gravity may continue collapsing inward without stopping. The result would be a black hole. A region where gravity becomes so intense that even light cannot escape. Scientists still debate which fate awaits Betelgeuse. Current estimates suggest it may leave behind a neutron star, but uncertainties remain. The star continues losing mass through powerful stellar winds, and every outburst changes the calculation slightly. Meanwhile, telescopes keep watching. Space observatories track infrared emissions from dust clouds surrounding the star. Ground observatories monitor brightness changes and surface activity.